What is a time interval?
The interval between two different times.
Okay, nope. You can't use the word, Sky. You just switch over to the word and that's how you're defining it. That's not how it works.
I think I know what it is.
Common sense, guys. Common sense is your guide, right? Physics is a lot of common sense. So what is a time interval?
Can I get it? Okay, all right.
Kyle, what are you gonna say?
I'm gonna say the distance between measurement, like meters. I don't know how to explain it.
Okay, it's a time, right? What's the units on time?
Second.
Seconds. So if we're talking about time and we're talking about seconds, then why are we worried about meters and distances?
I don't know.
Okay. Time interval, what is it? You said distance again. Guys, use common sense.
The amount of time it takes the object to
You can't use time.
You can't use time or just time between. No.
Time that is shifting. Can you not use time? Can you use time?
I just want you to use common sense. I don't care what words you use.
Alright.
Interval
So measurements of
of time.
it's the space between two different time.
Okay.
How long?
Back to our motion diagram, right? On here, how often do I put the dots?
Every second.
Okay, we changed every 2 seconds, right?
Oh.
Right?
Yeah.
Okay, we'll go back to every second since that's what you have in your go back to every second since that's what you have on your paper. Okay. Now we're back to every second, right?
Yeah.
Right? Yeah. So, what's the time interval between here and here?
4 seconds.
How do you know that?
Because
There's 4 times.
There's 4 dots, right? So the time interval is what?
4 seconds.
Okay, it equals 4 seconds. By definition, what's the time interval?
1 second.
I started here, I ended here.
The difference between the start and the end.
Okay, then we got an equation now.
the amount of time
Okay.
it takes. The amount of time it takes for an object to get from one point to another.
But not just an object.
Anything.
Anything. Okay? The time interval is how long it takes. Right?
Yeah.
As simple as possible. How long it takes. Right? When I ask you guys for a definition, guys, that's what I'm looking for. Make it as simple as possible. Okay? Simplicity is better than complex. Alright? So the time interval known as how long it takes an event. I put in parentheses, I put a little s, or events, okay, to occur. Well, I mean how long it takes an event or events. That's what little parentheses mean, right? To occur, right? It's okay. Kevin, you gave me an equation. What was that equation you gave me?
Time it takes for one thing to get.
Oh, that's not the equation. Now you're using words again. You gave me an equation. What's that equation you gave me?
K equals.
I didn't give you an equation.
Yes, you did.
Yes, you
I don't remember that.
Everyone remember his equation? Okay, we'll get back to it then. This triangle, what does that mean? Change. Change in time equals. Anybody know?
Speed.
Okay, let's look back at our motion diagram. Okay. I want to figure out the time interval between the first dot and the fifth dot on the top motion diagram. What's the time of the first dot?
1. 0.
0, right?
Yeah.
Time here is 0. What's the time of the fifth dot?
5.
Nope. 1, 2, 3, 4, 5. What's the time of the fifth dot?
6.
Okay, here's 0, right?
4.
Here's 1 second. Here's 2 seconds. Here's 3 seconds. Here's
4.
4. Good.
No,
Wait. Oh, all right.
Okay.
It's the difference
So-
between the start and the end.
What is it?
Difference between the start and the end.
What does difference mean?
Division.
Subtraction. Good. So, what is the time interval between the first dot and the fifth dot, Caleb?
4
Okay, pay
seconds.
attention. What's the time interval? 4 seconds. How'd you get that, Skylar?
4 minus 0.
4 minus 0.
Good job.
Does that make sense?
So it's t final minus t initial.
There you go. So our time interval is t final minus t initial.
Might want to get that down.
Looks a lot like our displacement equation, doesn't it?
Yeah.
Are there any questions about that? No? Okay. Now, can you guys all do subtraction?
Yeah.
Yeah. Okay. So, a lot of times, guys, this time interval report, I'm not going to say, what's the time interval between this spot and that spot on your test? I'm not going to do that. Okay? You all can do subtraction. Okay? The part about time interval might be an underlying part of a problem. Like, it might ask for the velocity or the speed of the object between two spots. And then you're going to figure out the time interval to work your way through. Okay? Does that make sense?
Sure.
Okay. What was I going to tell you next? I was going to tell you that, but that was going to be at the end of class. All right. So, on our motion diagram, we have t equals 0 and t equals 4, right? That's our first dot and our fifth dot. Can we figure out the time interval between the third dot and the seventh dot on the top? Can you figure out the time interval? We have 0, 1, right?
7 seconds.
2
Or
seconds.
6 seconds.
3 seconds.
4 seconds.
4 seconds. 5 seconds.
Oh, you
6
skipped.
seconds.
You skipped
Oh, I got 4 twice, don't I?
Yeah.
5, 6, 7, 8, 9, 10, right?
Yeah.
Right? So, can you guys figure out the time interval between the third dot and the seventh dot?
It is.
Where's my third dot?
It is 4 seconds.
Okay, hold on a second, Scott. Where's my third dot?
Where the 2 seconds is.
2 seconds. Where's my seventh dot?
And 6 seconds is.
Okay. So, to figure out our time interval, what do we do with those two times?
6 minus 2.
6 minus 2, what does that equal?
4.
4. Does that make sense, guys?
Yep.
Yeah? You guys with me? Okay. So time interval is pretty straightforward, right?
Yep.
Okay. Are there any questions?
Nope.
Okay. Now, on your pink paper that I've given you, okay? 3 says determine the time interval between the first dot and the last dot on each of the motion diagrams. Okay? I want you guys to do that. Okay? And the last one, the last little question, it's still part number 3, says, how could you use the time interval to determine the speed of each object? Okay? So determine the time interval between the first dot and the last dot on each motion diagram. Okay? Now the first dots all have time of what?
0.
0. Okay? Like all these objects that are moving are equipped with a stopwatch, and once they start moving, that's when their stopwatch starts. So all those initial times are 0. So figure out the time interval between the first and the last on each motion diagram.
All right.
Try something. Don't just wait for me to do it. Try something. Use pencils, so if you make mistakes, then you can erase them.
Alright. You can check this page.
I think you can tell if you're right or wrong, Skyler.
Come on, dude.
I mean, for the class.
Cool. Okay, use the last dot. Where's your last dot?
Okay. Number 5. Number 3.
George, why don't you write that down? Okay, first one. What's the time of the first dot? 0. What's the time of the last dot? 10. So to find my time interval, we do 10 minus 0, which is 10 seconds. Good. Next one. And what's my first dot?
0.
0. What's my last dot?
5.
Sure.
Yeah.
Is that the same spot as this one?
But it's
Is that the same position coordinate?
but it goes 2 meters in 1 second.
Oh. So this is really
1 second.
1 second.
2 seconds. 3 seconds. 4 seconds. 5.
Good. So this is 5 seconds. That means delta t equals 5 minus 0, which is
5.
5 seconds.
Then the next
Oh.
one is 2
What about this one?
2.
What's the time of our last dot?
2.
2. Okay. So the location on this axis has nothing to do with our time, does it?
No.
No. The number of dots tells us the time because the dot's made every second, right? Right? So our time interval here then is delta t equals 0, or sorry, not 0, 2 minus 0, which is 2 seconds. Right. Does that make sense, guys? Okay. Now the second part of that question says, how could you use these time intervals to determine the speed of the object? Okay. Now, this is kind of all put together, all what we did so far put together. Okay. We did a little bit with displacement, right? Right? We did a little bit with time interval. So how can we take those two things and kind of put them together to figure out the speed of the object? What do you guys think? What do you guys think? How can I find the speed? Anybody know the units on speed? Meters per second, right? What's a meter? What's a meter? What? A distance, good. What's a second? A time. What does per mean?
Per means division.
Division, right? So how can we find the speed? Distance over time, right? So to figure out the speed of these objects, we could take the distance it's traveled, right, and divide it by time. Now some of you are probably thinking, well, how does displacement work into this whole thing? You just said distance, Mr. Branch, right? So speed equals distance over time. Well, remember yesterday we talked about displacements. Then we also talked about vectors. Now vectors have magnitudes and directions, right? A displacement is a vector, right? The direction is which way we moved. What's the magnitude? The length. What's the length? The distance, right? So speed is equal to the magnitude of our displacements divided by time. Now, how do I know this is magnitude and not actually displacement?
Because of the triangle.
Not because of the triangle. What does displacement usually have? Look at equation 1 over there on the board. What does displacement usually have?
A vector.
A vector. Is there a vector up here?
No.
No. So that means that this is the magnitude of the displacement or the...
Maximum.
No, not the maximum. The magnitude of the displacement, also known as the
Distance.
distance.
Yeah.
Right? The distance divided by time. That's how we find speed. Does that make sense? So if I take the distance of each of these motion diagrams and divide by the time, what are you going to get? Well, what's the distance traveled by this one? Here's the displacement over the whole time, right?
It went 10 meters.
Right? How long is that vector?
10 meters in 10 seconds.
10 meters in 10 seconds, right? So we do 10 divide by
10.
10.
Get
10
one.
divided by 10 is
1.
1. The speed here will be 10 over 10, which is 1 meter per second. Is that just a coincidence with this? Just a coincidence?
No.
No, it's not a coincidence. Okay. What about this one?
10. Divided by 5.
Here's my displacement vector, right?
10 divided by 5.
Right?
Yep.
How long is that displacement vector?
10 meters.
10 meters. Okay? How much time did it take?
5 seconds.
5 seconds. So speed equals 10 over 5, which is
2.
2 meters per second.
What a coincidence.
What a coincidence. Everything's coincidental, right? Last one. Okay, Scott, you can't say anything now. Okay. Here's my displacement vector. Right? How long is that? 8. So the distance is 8. What's our time? 2 seconds. Speed equals 8 over 2, which is 4 meters per second. Does that make sense, guys? Yeah. Any questions? Okay. is our next example. If you want to draw it, you may, or you can just label example 2, unit 2, example 2 in your notes. Okay. You need to describe the motion of each of the objects. Okay. Describe the motion of each of the objects. You can use the back of that page if you want to. Back that pink page. The one side of the pink page that you just did, I will make you turn that in so you can write whatever you want on there. You can write how much you don't like Mr. Branch. I won't read it. Unless you write your name on it, then I'll know. Now, on these motion diagrams, the number inside the circle tells us the time. So that first object, everything starts at 0. So for object 1 and 2, that's over on the left. Object 3, that's over on the right. And then each number inside the circle, that's the time that's elapsed. Okay, so it's like time equals 1, time equals 2. So the time interval of this is 1 second. Every second we're getting a new dot. Sir? Jimmy, where's your work? Come back. Where's your work? Make sure you do that. The main part. Okay. Divide by, take your arrow on, hit enter, and you divide. Okay. So that keeps the main area. Okay. So, like this. Look at all these, they're all on 10, right? They're average VA. Okay. Describe the motion of these objects. This we're just figuring out displacement vectors. Here we're just figuring out speeds. The time interval, the time doesn't have an arrow on top, so it's not a vector. Okay. All right, object 1. Anybody want to describe the motion? Anybody know how? Kyle, what do you think?
I'm not raising my hand.
Oh, looks like you are. Skylar?
It was going 1 meter per second between 0 and 1, and then it accelerated. And wait, yeah, 1 meter per second, then it started to accelerate. Object 1, it was accelerating.
Are you sure it's constant between 0 and 1?
No, because it's accelerating at every other point.
At every point?
It's accelerating throughout the thing.
Yeah, it's
Throughout the whole time?
Although 3, 4, it seems like it kind of gets to the end point of its acceleration.
Yeah, between 2 and 3 and 3 and 4, it's the same speed. So it's accelerating between 0 and 2, and then it just goes constant after 2.
You sure it's constant after 2?
Yeah,
That's
because
not
it's the same interval between, the same time interval between each point.
Unless number 5, if you predict number 5 is
Okay. So, object 1. Which way is it traveling? In the positive direction or negative direction? Positive. Based on how we defined our axis, it's traveling in the positive direction. So we can say object 1 is traveling in the positive direction with an
Acceleration.
okay. I don't know that word yet.
Speed.
Okay, what's happening to our speed?
Increasing.
Increasing speed, right? Okay, right now we're not worried about accelerations yet. We haven't learned about those yet, so we don't need to have that in our vocabulary just yet. Okay? Well, you can use that word if you want to. Because acceleration is a change, not in speed, but a change in velocity, and we'll get to that later. Right? So by using it, just talk about speed can be a little bit confusing. Alright, so we'll just talk about increasing and decreasing speeds right now. So, object 1 travels in the positive direction and has an increasing speed until when?
Until 2.
Until 2? Now it says until 3. Are you sure it does not increase its speed at all in here?
It does.
It does.
It does. It could increase the speed in there, right? Right? So where are you certain that the increase stops?
3.
After 3. Okay. So this is moving in a positive direction with an increasing speed until 3 seconds. Then from 3 to 4, it's as a constant speed. Okay. Now you could be correct. It could increase until 2 and stop increasing. That could be the case. All right. But it's also just as likely to increase until 3. So I would say it's increasing until 3. Okay. Because I remember we talked about yesterday how we had that radar gun, right?
Mm-hmm.
The average speed happens in the middle,
Mm-hmm.
right? So I take this distance and divide by my time. That average speed would probably the speed of the object right here. So the speed at 2 is greater than 2 meters per second, right? The speed at 3 might be greater than, if it increased the whole time, the speed at 3 would be greater than 3 meters per second, right? But because it's constant after 3 and it's the same as at 2, then the changing, the stop of the increasing probably happens somewhere between 2 and 3. Okay. Does that make sense? Object 2. You want to take a crack at this one?
I think I can get it.
Think you got it, Kyle? What is it, Kyle? Positive or negative direction?
It's going positive.
Positive direction. Perfect. What else?
See, what happened was it was going fast and then it slowed down
So it's going fast and it slows down. How do you know it slows down?
because they're getting closer to each
Where does the closeness happen?
other. After 2.
After 2. Good. So from 0 to 1, from 1 to 2, what do you know about speed?
It's the same. Constant.
Constant's the same, right? Then from 2, what does it do, Kyle?
It, decelerate.
Don't use that word. The speed increases or decreases?
Decreases.
It decreases, right? Until when?
Until object till after I don't know. I don't want to.
Can someone help Kyle out? Decrease until when?
3. Wait, no, 4.
4. Okay. Decrease until 4. It could have stopped decreasing at 3, but just to be certain, we'll say it stopped decreasing at 4. Okay. The stopping of decreasing is probably somewhere between 3 and 4. But we'll say 4. Does that make sense, guys? So object 2 travels in the positive direction with an increasing or with a constant speed until 2 seconds. At 2 seconds, the speed starts to decrease until
4.
4, and then from 4 to 5, it has a.
Constant speed.
We can assume it's constant. Based on what we see. Yes, Kyle.
I'll do that now.
We're going to do the next one. We turned it to the second one. Okay. Object 3. Someone new. Object 3.
Oh my
Someone
gosh.
new.
Got it.
You got it? Okay, Jose, where does it start?
Well, let's go with negative direction.
Okay, so it's going in the negative direction. How do you know that?
It starts at 5.
Because here's 5? But where does the object start?
At the other side.
The other side. Object starts here. Okay, what else, Jose?
It's a constant speed
How do you know it's constant?
because the intervals are the same.
Time or distance? Trick question, both. Okay. No, you're right. You're right. So Jose is exactly right. It's traveling in the negative direction because 0's all the way over there, right?
We have a question.
What's that, Stephanie? Danielle. Gosh, you did that 2 days in a row. Sorry, Danielle. Stephanie sits right where Monty sits there an hour before.
How do you know it's time? I know it's distance because it's going like the same. You know, it's different. It's the same distance between each other, but how do you know it's time?
Okay. The time interval here, because I told you that the number is the timing is the time on the stopwatch. Okay.
So what is an example of not being a time?
If the same time, if it wasn't the same time rule each time, if let's say this one was gone, I said here's 0 seconds, here's 2 seconds, here's 3 seconds, 4 seconds, and so on. That wouldn't be a constant time interval. But these particle diagrams, Daniela, only work if we have a constant time interval.
Yeah. Okay.
Okay? If the time interval is unconstant, then it's really hard to tell what's going on. As well? No. Okay. So 0, 1, 2, 3, 4. The time interval is 1 second the whole time, right, Jose? Okay. And the distance is always 2, right? The distance is always 2. So that means this one is traveling at a constant speed in the negative direction. Does that make sense, guys? Yeah. Now, you remember from the little activity we did earlier, we talked about speed? What's kind of a word definition of speed? And I don't want how fast it's going. Okay? I want how fast it's going. What's kind of a word definition of speed? It's the amount of what? Cal?
I don't want to say it no more.
Distance traveled in a certain amount of time, right? So generally speaking, when we record speeds, we say meters per second, right? Right? What's this one's meters per second? How many meters per second?
2.
2 meters per second, right? So that means every second this object goes how many meters?
2.
2 meters.
Negative
Right.
2.
That's what speed means. If I have a constant speed, that means every second we're traveling that number of meters, which is our speed. Okay, so the object 3 has a speed of 2 meters per second. So it means every second it's going 2 meters. Okay? Does that make sense? Okay. Last thing on here. Rank the objects based on the magnitudes of their displacements between 0 and 2, 3 and 4, and 0 and 4. Okay? Now, you don't have to draw this out on your own paper if you don't want to. Okay? And I have some marks on my board that I need to erase. This isn't too jumbled. Okay. So, between 0 and 2, 3 and 4, and 0 and 4. So, where's time 0 and 2?
Right here.
Right here, right?
Yeah.
So what's the displacement? I could do the vector addition, or we could use that little shortcut we talked about, right?
Yeah.
So what's my shortcut?
1 to 2.
I draw the vector from
1 to 2.
1, 0,
from
1.
where we started, right?
Yeah.
To where we're ending, right?
Yeah.
So that's our displacement from 0 to 2.
Yeah.
What's our displacement here from 0 to 2?
6.
Displacement? Okay, Steve.
Yup.
About this one?
No, you gotta go that way.
Where do we start, Kyle?
Negative. On that side.
So the vector's pointing the other way, right?
Mm-hmm.
So rank them based on their displacements from 0 to 2. So which one has the greatest displacement?
Object 2.
So this one's the biggest, right? Right. Which one's the next biggest?
Object 3.
Tied.
Object 3.
Object 3, you sure?
Yeah.
No.
What is
Yes.
negative?
Ooh.
What? Well, if I
But
just said displacement, it would.
It's in distance though.
But we're talking about
Magnitude.
magnitude. Does magnitude have direction?
No.
No, so we're really looking just at the
Line.
distance. Right? So this one has the biggest distance, which has the next biggest distance?
Object 3.
Object 3. Okay. So this one is the biggest, this one is the second biggest, and this one is the third.
Church.
Alright, you guys try B. Okay? You can just do it visually with your eyes if you want to. Or you can do it on paper.
Got it.
B is time 3 to time 4. The largest displacement to the smallest displacement between 3 and 4. Yes. Can you get some water? Yes, you may. All done now, sir? Oh, where's your insert? At least like show me what you did up here with these, okay? All right.
You go up there and draw it.
You want to draw? Which one, Kyle?
I don't care.
Pick one.
I'll do number 2.
I want to do number 1.
Kyle wants to do number 1. Skylar called number 2. Oh, nice catch. Is there anyone who wants to draw number 3?
Crazy.
Anyone wants to draw number 3? Anybody else want to do YouTube Infamous?
Infamous?
Yeah.
Why is it gotta be
You might want to have
I don't know, lock draw it.
We're doing 4 to 3 or
3 to 4.
Omar.
Oh,
Draw a little
that's-
darker. It's got a
No.
Gotta erase all the marks. Just draw a little darker.
You know it's gonna like yellow.
Yeah. Although I think the bright light makes the marks go away. Okay. Anybody else want to draw 3 to 4? Oh, you already did one. Anybody else? Yeah, I'll draw 2.
You might want to.
Awesome. Alright. So, which one has the biggest magnitude?
That one.
One on top? Why is it one on top, Omar? The magnitude equals 3?
Yeah.
What's the magnitude equal here? 2. What about here? 1. So 1, 2, 3. Does that make sense?
Yeah.
Now the last one. From 0 to 4, that means my displacement vector starts where?
At 0.
At 0 and ends where? At 4. So, which one has the largest displacements?
Object and 2. 1 and 2.
They're equal.
It was really a rhetoric, just to get you guys thinking about it. That's okay. Just so excited, aren't we?
Oh,
There's displacements for 1 and 2, right?
Yep.
Where's the displacement for 3?
It's from 0 to 4 the other way. And it's only 8 instead of 9 like the other 2.
So which one has the biggest magnitude?
1 and 2.
1 and 2. Which one has the smallest?
3.
Does that make sense, guys? Quick question. Which object has the greatest speed during the whole time? Which object will have the greatest speed?
Both 1 and 2.
You're making an assumption, aren't you? What assumption are you making, Skylar?
The object one stays the same. I think it's
No, I'm not. It's because it's the interval from 0
3.
to 4.
Skylar said 1 and 2 have
What about
Skylar said that 1 and 2 have a tied speed, right?
Yeah.
What assumption is he making about the speed I'm asking for? He's assuming it is what? He's assuming it's not instantaneous. He's assuming it is
The same.
Constant.
constant. He's assuming I'm asking for the use an A average speed, right? But which one has the biggest instantaneous speed?
Object 2.
Okay, Kevin, you said object 2 where?
From 0 to 2, it's
Yeah.
more instantaneous.
Yeah, it's object 2.
From 0 to 2?
Yeah.
Okay. Or from 1, could be 1 to 2, right?
Well, it could be 3 to 4 on object 1.
Ah, there you go. It could also be 3 to 4 and object 1. So maybe we're making the average assumption, but I think you were. Okay. So, object 1 or object 2 could have the greatest instantaneous speed, right? Which one has the greatest average speed?
They both have the same average speed because the 9 is 4. Like the 4 seconds, the 9 meters and the 4 seconds.
1 and 2 could have the greatest average speed. We'll get that later. That's kind of a little bonus material, like a preview for the next stuff, right? Are there any questions? Any questions?
No.
No.
Bitch.